for this video, we're going to be covering two examples of implementing the following Boolean equation or equation given using 8x1 multiplexor. So let's get started. The first one is going to be our ones, meaning these are our ones. So I'm going to write this out. Now, we only truly need our D's for this. So D, I'm so sorry about that. D for 0, 1, 2, 3. Actually, make this smaller. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So 0 is a 1, 2 is a 1, 5 is a 1, 8 is a 1, 10 is a 1, and 14 is a 1. The rest are zeros. Now I'm going to take this and scoot this over because they're not our T's. These are our problems, RE, what our outputs are. These are our outputs, also known as F. Then we're going to have our D's. Our D's are 0, 1, 0, 1, 0, 1, 0, 1, all the way down. So I'm going to write that down. 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay. Now, I'm going to break these up into twos, into pairs. So this, we have pair, 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 and then our last pair. And the reason I do this is because we have 16 parts. So 0 through 15 is 16. I have an 8x1 multiplexor, meaning I need 8 outputs. 16 divided by 8 is 2. So I need pairs. So this is going to be our I0, I1, I2, I3, zoom out, I4, I5, I6, I7. So we have a total of 8. 0 through 7 is 8. Okay. So when looking at this, I7 or I0 is equal to D prime, because when our F is 1, our D is 0, and when our F is 0, our D is 1. So it's D prime. It is the exact opposite. Our I1 is also D prime because it's the opposite. Our I2 is equal to D. Our I3 is equal to 0 because always 0. Our I4 is equal to D prime. I5 is D prime. I6 is 0. And I7 is D prime. So I am going to draw a quote-unquote multiplexor. Boom. My output is going to be F. I'm just going to call this MP for multiplexor. I am then going to have my outputs, or my inputs. So it's A, B, C. And then so this is our S0, S1, and our S2. Now I need my I's. So I have I0, I1, I2, I'm running out of room, so I3, I4, I5, I6, and I7. So first thing I'm going to do is I0 is, so I'm going to draw a D. So I have D, and I'm going to come down all the way down from this. Boom. And then I also have my D prime. to draw my prime, I'm just going to use an inverter. And I'm sorry, I don't know why I did that. I'm going to come down like this. And my last thing is I have ground. And I'm just going to draw ground here because ground is 0. You can use 0 or you can use ground. It doesn't really matter. So I'm going to bring this all the way up. Okay, I'm going to use a different color just so it's clear. So we said our I1 is equal to D prime. So I'm going to take this, hop over, that's my I1. I2, sorry, our I0 is D prime. Our I1 is also D prime. So take this, jump over, through. I2 is D. This is D. Our I3 is 0, so our ground. Our I4, D prime. I5, D prime. I6, 0. And I7 is D prime. So this one. Okay, and that is how we solve this equation. I left an extra page just in case I needed it, but I ended up not. Okay, so our next one, our next example, we're going to implement this into a 8x1 multiplexer. These are our zeros. So I'm going to do the same exact thing. I have my 0, 1, 2, make it big, 3, 4, 5, 6, 7, 8, 9, never out of room, but we'll see, 10, 11, 12, 13, 14, just enough room, 15. So this is our D. We don't really need to worry about our A, B's, and C's. We really don't. We know what they're going to be, and that's fine. And our F's. So I'm going to come down, right in the room, down. Oh, okay. So our 2's, which is here, our 2 is 0, our 6 is 0, and our 11 is 0, and everything else is a 1. 1, 1, 1, 1, 1, 1, 1, 1. For D, it's 0, 1, 0, 1, 0, 1. So 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Same thing. I have an 8x1 multiplexer, but I have 16 outputs. 16 divided by 8 is 2, so I need pairs. So this will be my first pair, second pair, and so on and so forth. We need pairs. Pair, pair, pair. So I'm going to start here. I'm going to zoom in just so we can see exactly what we're doing. Our I0 is equal to, it's 1. So we're going to write 1. It's always 1. I1 is D, because it's equal to D. I2 is 1. I3 is D. I4 is 1. I5 is D prime. I6 is 1. And I7 is 1. Now over here, I'm going to draw my multiplexer. Move it a little bit further to the side so we have a little bit more room than we did last time. I'll draw it here. I have my inputs. So I have A, B, C. My output of X. I'm just going to call this multiplexer. This is our S0, S1, S2. Now I need all of my I's. So I have I1, I2, I3, I4, I5, I6, and I7. Perfect. We don't have any zeros, so we don't need a ground. We have D and D prime and 1. 1 is just equal to voltage. Now, there are two ways you can do this. You can either write 1 and just have 1's connecting to 1, or we can use VDD for voltage through D, so it's always 1. I'm just going to do VDD. I like it. I prefer it. And I'm just going to do VDD. So the first thing I'm going to do is take my D all the way down. Then I have my inverse of D. And then I have my VDD. So this is my voltage. Sorry, I don't know if I did that again. Move that. Perfect. So now we're going to come back here. Our I0 is 1, so voltage. So I'm just going to do dot and a dash in. I1 is D. I'm so sorry. I didn't write I0, so I need to do an I0. I0. I0 is 1. Our I1 is D. Take my D, hop over, straight in. I2 is 1. I3 is D. So take the D, hop over. I4 is 1. I5 is D prime. So D prime, hop over. Our I6 is 1. And then our I7 is also 1. And this is how we do a multiplexor. If you have any questions, please let me know. I'm more than happy to explain. There are no further questions for this one, though.